All right, so let's talk about this next unit that we're going to be studying, which is systems of equations. You've done a couple of lessons on Desmos, and hopefully what you've learned from that is a system is multiple equations to model multiple relationships. So, more than that, I know a couple of you got the idea that a system of equations was multiple equations, a set of equations. So, what becomes important is what is a solution to a system of equations? So, a solution to a system is an xy value, an x and a y value that make both equations true. Okay, and a lot of times that's represented as an ordered pair. So we might see that as x comma y, like you did in Desmos for those 2 days. So as an example, if I give you the point 2, 5, is the point 2, 5 a solution to? Okay, let's do 2 different examples. One, if you have the system y equals 4x minus 3 and 2x plus y equals 9. Here are multiple equations with 2 different variables, and I want to know if 2, 5 is a solution to that. Well, keep in mind that 2 represents an x value and 5 represents a y value. So we want to know, does this x and y value make both of these equations true? And the easy way to figure that out is to plug in the values and see if they check. So since y is 5, I would ask myself, is 5 equal to 4 times x, which is 2, minus 3? Well, 5 is equal to 8 minus 3, which happens to be 5, so yes, that point does check in that equation. I do have to check in both equations. So now let's do the same thing with the other equation. Is 2 times x, which is 2, plus 5 equal to 9? Well, 2 times 2 is 4, plus 5 is equal to 9. It is in fact true, so the answer to this is yes. The point 25 is a solution to that system of equations. Okay, well, is it a solution to y minus x equals 3 and y equals 1/2 x plus 6? Okay, let's use the same point, try doing the same thing. So let's see, y is 5, so is 5 minus 2 equal to 3? Well, that's easy. 3 is in fact equal to 3. Now let's check the other equation. Is 5 equal to half of 2 plus 6? Half of 2 is 1. 1 plus 6 is 7. Is 5 equal to 7? No. Okay, so what that means, the point 25 is a solution to this first equation, but not the second, which means that it is not a solution to the entire system. Okay? Well, that's what it looks like algebraically. What does it look like graphically? If I asked you to graph these two things, what does that solution look like? That's what we're going to find out now. So let's grab a piece of graph paper, and since you don't have graph paper, you can just sketch this. Okay, but here's our x and here's our y. And I want to look at the system. So the 2 equations I want to look at are y equals 2x plus 5 and y equals 2 minus x. Okay, let's keep in mind the things that we know about these 2 equations based on the last unit that we did. In this, the slope is 2. If I make that a fraction, it's 2 over 1. And the y-intercept is 5. Here, the slope is negative 1 over 1, and the y-intercept is 2. Okay? So I'm going to graph those two lines. And again, you can do this just by sketching if you'd like to. The first equation has a y-intercept at 5, so it's 1, 2, 3, 4, 5. And the slope is 2 over 1, which means go up 2 and right 1, up 2 and right 1. As long as I have 3 points, I'm ready to graph my line. So I use a straight edge. And there is my line with arrows and a label of y equals 2x plus 5. Now I graph my other line, which has a y-intercept at 2. And the slope is negative 1, so I go down 1 and right 1. Okay? And if I draw that line, that's y equals 2 minus x. So what do I notice? Well, I hope you do. I notice that these two lines cross each other right there. What are the coordinates of that point? Well, they're negative 1, positive 3. Negative 1, positive 3 is the solution to this system of equations. So I'm going to say, based on my graph, that the solution is negative 1, 3. What I do want to be able to do is verify that. So let's keep in mind that this is x and this is y. And I can check that into both equations. I have y equals 2x plus 5. I think I know what x and y are. So that would be 3 equal to 2 times negative 1 plus 5. And that does, negative 2 plus 5 is 3, so that checks out. I have to check it in the other equation too, remember. So this is y equals 2 minus x is 3 equal to 2 minus negative 1. Well, there's a double negative. 3 does in fact equal 3. That checks out. That is in fact the solution, which I can verify algebraically and graphically. Okay? So, long story short, the solution is the point of intersection. Okay? Earlier we talked about a solution is the x and y value that make both equations true. On a graph, that looks like the point of intersection. Okay. So, and that point does check into both equations, making both equations true. All right. So the last thing I want to look at, again, I'm going to show you a problem that I'm going to go through, and I want you to consider sketching this so that you have an idea of what it really looks like, because some of the work on Monday will look like this. Okay? So here's a problem that I'd like us to look at. It's exercise 4. Janelle and Swetha are taking a 50-question true-false test in their history class. Janelle started after Swetha had already finished 12 questions. Janelle answers questions at a rate of 2 per minute. That's important information, while Swetha answers them at a rate of 5 questions every 4 minutes. Janelle eventually catches up to Swetha. How many minutes does it take her, and what question are they on when Janelle catches up? So we're looking for how many minutes and what question are they on. So the first part of this problem, you'll notice that there's a graph. They want us to graph this so that we can figure out this answer. Well, in order to graph, we need to write equations. Okay, the two variables, as we can see, are the number of questions answered and the number of minutes gone by. All right, but we are talking about two people. We're talking about Janelle and we're talking about Swetha. So what would the equation for Janelle look like, knowing that it says she answers questions at a rate of 2 per minute? Well, we know that rate of 2 per minute means slope, so that would be y equals 2x. And then Swetha answers at a rate of 5 questions every 4 minutes. Well, that would be 5 questions every 4 minutes. And it does say that she already finished 12 questions, so we've got to include the 12 questions that she already did. Okay? All right. Now you could put these two equations in your calculator to get some of the points. That's actually not a bad idea, so if you get out your graphing calculator or use Desmos if you would like to. Y equals 2x, I'm going to graph first. I do notice that this actually goes by ones, and I do actually notice that this goes by 2, 4, 6, 8 twos. Okay, so when I look in my calculator, I see that we have 0, 2 as a point. I see that we have, 0, 0, 1, 2, 2, 4, 3, 6, 4, 8, and so on and so on. So I plot a couple of points. I graph my line. And keep in mind that I've asked you all year to use the entire graph. Hopefully now you're going to see a reason for that. Okay. If I use my calculator to get some other points for the other equation, okay, keep in mind that that one was 5/4 x plus 12. And because there's a fraction, there's probably going to be a whole bunch of decimals involved in this one. I'm going to skip those. So I see the point 0.12, so 0.12 is right there. My next point is 113.25. I don't really feel like estimating where that is. The next nice one I see is the point 417. So 417, well, there's 12, 14, 16, 18. So 417 is something like right about there. Okay. My next point, good one that I'm going to use, is 822. So 6, 7, 8. And 22 is going to be right there. My next good point is 1227. So 12 and 27 is 2, 4, 6, right about here. And I also see the point 1632, which is right there. So I've got enough points to connect and make my line. And I do notice, and here's the whole idea, that these two lines cross each other, have the same point right there at 1632. And that is actually the answer to letter B. Graph the two equations and solve the problem. Well, the original problem was to find out how many minutes does it take her and what question are they on. Well, this is the point 1632. The 16 is the x value, which stands for the number of minutes, so it's 16 minutes. 32 is the y value, which is the questions answered, so they're on question number 32. Okay, so this is the kind of thing that we're going to continue working on when you come to class. If you have any questions, please let me know. Be ready to ask as class begins. Have a great weekend. Bye.